Hello, my name is Vargas. This is lab 4. So for the first task, we have to explain the code that we did. It's a pretty simple code. We are just connecting the potentiometer and the end scope to analog points 1 and 2 on the Arduino. And we're just we're dividing the readings on the potentiometer, dividing them by 4. So there's like 4 different ranges, and then on every range there's going to be a set frequency for every range, and then that's what the processing code is going to read, and it's going to give us the sine waves that we're looking at. Now I'm going to be presenting each result for the different sample frequencies we had. I'm going to show one by one because the resolution doesn't look too good when I show 3 at the same time. So this is for 416 with 75 Hertz. This is at 100 Hertz, 215 Hertz, and 300 Hertz. Now for a sample frequency of 186, this is what I got at 75 Hertz, at 100 Hertz, 215 Hertz, and 300 Hertz. Now for a sample frequency of 136, this is what I got for 75 Hertz, for 100 Hertz, for 215 Hertz, and for 300 Hertz. Lastly, for 97 as my sample frequency, this is what I got for 75 Hertz, 100 Hertz, 215 Hertz, and 300 Hertz. Now these are my calculations. As you can see, we already know the sample frequency. We can find an implicit frequency just by dividing the sample frequency by 2. Then to find the theoretical frequency, we just use the following formula, which is the frequency we're using minus the sample frequency times the frequency divided by the sample frequency, and you just round that up to the nearest integer. And all of that, it always has to give you a positive value, so you just take the absolute value of everything. So that's what we did for every single one. Now these are my results for the table. So for part 2, now we need a square wave, and in order to do this, we changed the output from analog 1 to pulse 1, and this is what we got on the end scope and on the processing. Since the sample rate is really high, as you can see, it's at 419 right now, and it's only at 10 Hertz, the samples are going to be really precise and there's not going to be any variations. Now for the second part, we need to do a triangle wave, so we change it back to the analog 1 output, and this is what we get in the end scope, and this is what we get at the processing code, as well as the last one. Since the sample rate is really high and we're only creating waves at 10 Hertz, it's going to be really precise and it's not going to vary at all.